Okay, so more wave mechanics. The note on a violin string of length 30.6 centimeters produces a wave with a speed of 274.3 meters per second. What is the first harmonic of this note? Now, we talked about this in class, that harmonics deal with the waves, or parts of waves, that fit your problem. All right. So the first harmonic is actually going to be the first wave that fits. So let's take a look at a violin string. It's a lot like the guitar string that we've looked at in class. Now, we've got it pinned down on both sides. We're going to talk about that in just a moment. And we say that this length is 30.6 centimeters. And that there's a wave speed of 274.3 meters per second. And here's where we have to bring in some of the stuff that we've done in class. We have a string that's held down here and here, so we have a node on both sides. We have to find the wave that actually fits in here. So, draw a wave, just like I've taught in class. We have node, 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 antinode, 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 antinode. Not my best drawn wave ever, but it'll do. The first question is to find the first harmonic of this note. Basically what they want is they want the frequency that corresponds to the first wave that is going to fit in there. Well, we've got a node to a node. So I take my marker, I'm going to start on a node, and I'm going to draw the first wave or part of a wave that fits from a node to a node. I have 2 sections. So let's find out how much of a wave I have. Well, one complete wave is 1, 2, 3, 4 sections. I only have 2, so for my first harmonic, L equals 1/2 of a complete wave. And I know that my length is 0.306 meters. I'm going to convert it over to our SI, and that will be equal to 1/2 of our first wavelength. Well, I'll double this, and I should end up with, what is that, 0.612 meters equals the wavelength of our first harmonic, the first wave that is going to fit in our problem. Great. Now that we've got that, we can use the often used equation that the wave speed is equal to our wavelength times our frequency. So I fill that in. We've got 274.3 meters per second equals our wavelength that we found for the first one is 0.612 meters times frequency 1. That's our first harmonic. It's the fundamental frequency. There are a couple different names for it, but it's basically the first of the frequencies that we're actually going to have in here. It corresponds with the first wave or piece of a wave that fits in our system. So I take 274.3 and I divide it by 0.612 meters, and I find that my first frequency should come up to 448.2 hertz. Survey says 448.2 hertz. Awesome. Second question is, wait for it, what's the second harmonic? What's the second frequency, or the frequency of the second wave that will fit inside my problem? I still need to go from a node to a node. So this is one of the waves that can fit in there. It's technically part of a wave, but it's what fits between these. So I'm going to start on a node. I've already stopped on that node, so I'm going to go to the next one. This is the second harmonic, because it goes to the second wave that will fit from a node to a node. Great. Well, now I've got one complete wave in there, so I know that my length is equal to, well, just lambda, the wavelength, 1 times lambda. I know that my wavelength is therefore 0.306 meters equals lambda, 2, lambda 2. So then we can work through this. We've got our speed, 274.3 meters per second, equals lambda 2, which we know is 0.306 meters, times frequency 2. We go through and we solve these. 274.3 divided by 0.306 And we end up with, not surprisingly, F2, which is 896.4 hertz. Now you might start noticing patterns in the numbers that come out of this, and for those of you that are familiar with music, it's one of the things that you'll know where they talk about how the notes kind of follow a mathematical pattern. This is actually why. Now there's one more question on here, but I'm not going to do it. I'm going to leave it for you. They ask, to no one's great surprise, what is the third harmonic? What's the third frequency that this one is going to make? We'll come back up here. I'll get you started. Remember, you still have a node on this side and a node on that side, so we're going to go from this node, not to the first one, not to the second one, but over to the third one. How much of a wave will you have in that string now? It's not half a wave, and it's not one complete wave. I'll leave the rest to you, but repeat what we've done here and see what happens. Now, as a challenge, you could go and try and find the seventh harmonic, just as a heads up.